Okay, this video is a type of problem that you might see sometime where what's happening is they have a solution already, and in the solution there are some different types of ions. Now, then what's going to happen is somebody's going to be adding drops of a different type of ions into the solution, and you're trying to see which substance will precipitate first, silver chloride or silver hydroxide. So you're adding silver nitrate right here to this beaker. So what you have to think about is they're giving you the KSP, and so we'll just start with silver chloride. And so silver chloride, all right, what happens is it can go both ways here, and you can have Ag plus 1 plus chloride negative 1. Now, they're giving you the KSP here for silver chloride, and so the KSP is equal to, let's see here, 1.77 e to the minus 10. Now, if you write the expression for this, KSP will then equal Ag times Cl, Ag plus 1 times Cl minus 1. Now, that number is 1.77 e to the minus 10. So 1.77 e to the minus 10, that will be equal to this concentration times this concentration. All right? Now that's going to, when these concentrations are the maximum amount that can dissolve in the solution. When the concentration exceeds these numbers, then what's going to happen is you're going to get a precipitate. Now, anyway, what the person is doing is there's already chloride ions in the solution. So we know what that is. And so the chloride we know, so I'm going to plug that in, is 0.0030. Okay? Now, what we don't know is what the silver is. And so we'll call that X. But when this number times this number equals that number, that's the maximum amount that can dissolve. When this number gets slightly larger, because the person's adding silver nitrate, they're adding more silver ions. When that number times this number is greater than this, the reaction is going to shift to the left and make our precipitate silver chloride. All right, so we could solve that for X, and it ends up getting 5.9 e to the minus 8. So once your silver reaches that concentration, that's when you're going to just anything above that, when it exceeds that by a little bit, you're going to start getting a precipitate. Now we'll do the same thing for AgOH. So if we have AgOH solid, you put it in water, it's going to make Ag plus OH minus, but we're kind of interested in it going the other way, the backwards way, and forming a precipitate. All right, so we know the KSP for this one is going to equal Ag times OH. They're giving us the KSP, which is 2 e to the negative 8, is going to equal our Ag. That's what we don't know, so we'll call that X. And the OH is already in the solution, so that's already 0.00040. Okay, and so what we'll do is we'll solve for X, and we get that X equals for the OH is 5, well, it's not the OH, it's actually Ag. And so we get 5 e to the negative 5 molar. All right, so now here's what you got to think about. So the person is adding silver nitrate, and we're mainly concerned about the silver. So once the silver reaches a concentration of 5 e to the minus 5, then, or just slightly above that, we would start getting AgOH precipitated. Okay, when it reaches 5.9 e to the minus 8, we would start getting AgCl precipitated. So anyway, which is it going to reach first, this number or this number? Well, this number is a lot smaller because it's to the -8 molar, and it's a lot smaller than this number. So this precipitate right here, AgCl, would precipitate first because you don't need as much silver in the solution to make it start precipitating. Okay? So once the molarity of your silver surpasses 5.9 e to the -8, you're going to start getting the precipitate AgCl. You would not get to precipitate AgOH until the molarity of your Ag surpasses 5 5 e to the -5. So AgCl will precipitate first. That's the answer. Okay, why don't you try this next problem when you have lead nitrate is added to something that has iodide ions and chloride ions, and you're trying to figure out which will precipitate first. So try this video, or try this problem, and then go back to pause the video, then come back and see if you did it right. Okay, so the same type of problem. So what we're going to do is we're going to write the expression for PbI2. So when PbI2 gets put into the water, you're going to get Pb plus 2 plus I -1, but you got to balance this little equation here. All right, and then we're also going to have one for PbCl2. So PbCl2, when you put that in water, it's going to make Pb plus 2 plus 2 chloride -1. All right, these should be AQ. I guess I took a couple shortcuts over here, so I'll put that on there. So now what we know is we can write the expression for this. So the KSP for the PbI2 is going to be Pb plus I -1. This is plus 2. But this is to the second power. All right, that's the KSP for that one. We can write the KSP for this one. The KSP is going to equal the lead plus 2 times chloride -1, and that's to the second power because there's a 2 there. All right. Now, anyway, we can just do it like we did the last problem. Is we know the KSP for PbI2. It's 1.4 e to the -8. Now, what the person is doing, they're adding lead nitrate dropwise. Okay, so we don't know what the concentration of lead needs to be, so we could call it X, because we don't know what that's going to be, but we know that it already contains 0.050 molar of iodide ions. Now don't forget that that's squared in this problem. Okay, we already know that it contains that. Now we can solve for X, and if we solve for X, let's see here, we get 5.6 e to the -6. So 5.6 e to the -6 molar. Now what X is the lead. So when the lead concentration is equal to 5.6 e to the -6 molar, okay, that's the maximum molarity that you can make. Once it surpasses this 5.6 e to the -6, like let's say it goes to 5.7 e to the -6, then this reaction will go backwards and start making a precipitate. Okay, so that's for the PbI2. Now let's do the same thing for the PbCl2. So the KSP is 1.6 e to the -5. Okay, now we're not going to know the lead because we're adding that dropwise. Okay, but we know what the chloride ion concentration is, 0.0040 squared. Now, if we end up solving for X, let's see, this one ends up being 1.0 molar. Hey, that's nice, it made a number like that. So once the lead concentration reaches 1 molar or just surpasses it, like it could be 1.1 molar, but you're adding it dropwise. Once it surpasses that, this reaction is going to shift and go backwards and start making a precipitate. All right, so now if your person is adding lead nitrate dropwise, which molarity will lead reach first in the solution? Will it reach 1 molar first or 5.6 e to the minus 6 molar? Well, it's going to reach this one first because it's a smaller number. So what's going to happen is, because you're adding it, the concentration of lead will reach a concentration that's great enough to start a precipitate, to make the precipitate PbI2 before it will make PbCl2. So PbI2 would be precipitated first because once the lead surpasses this 5.6 e to the minus 6, the precipitate PbI2 will form. You see, it would take, to form PbCl2, the lead concentration would have to surpass 1 molar, and it would surpass this one first. That's why PbI2 forms. Okay, that's it.